Hey, how's it going? Hope you're doing well. Today we're talking about LeetCode problem 2620 counter. This problem is an easy problem, but there's some important key concepts we can learn from it, such as closures. So this video would be great if you're a beginner or you're trying to get better at LeetCode and just overall improve your programming knowledge. This video is perfect for you. So stick around for it. I'll show you the solution and some other solutions for it, and hope you enjoy. Alright, so we're going to be programming in JavaScript today, but feel free to program in whatever language you like. It just may be slightly different from what I'm doing. So before we start, you're going to want a strong understanding of the basics of programming. So for this problem, I'd say you need to have a strong understanding of functions, variables, and scope. I think once you get the basics down, you'd probably be able to solve this problem. So let's go ahead and figure out what we're doing here. Alright, let's go ahead and read our problem. So, given an integer n, return a counter function. So, we know that we're going to be giving something the value n. What we see over here, we're giving a function the value n, and then we're returning a counter function. Well, you see that right here, we're returning a function. So, what do we need to know about this function right here that we're going to be returning? Well, this counter function needs to initially return n. So whatever value we put in n, we need to return that right off the bat. And then we need to return one more than the previous value every subsequent time it is called. So other than the first time, we're going to add 1 to our n value. So, and you can kind of see that happening here in this output. So n is returned the first time, then we're adding 1 to it. And here we're adding 2 just because it's being added to this, but it's technically adding 1 to the previous value. Alright, and we can look at an example here. So what happens if we give our function the value 10? Well, we give it 10 and we call it 3 times. Well, we initially return 10 because that's what we're told to do, initially return n. And then we're adding 1 each time because add 1 to the previous value every time we call it after the first time. So it's just counting up. That's all it's doing. But us as programmers have to understand how to do that. Alright, so before I show you the solution to this problem and we work through it, I think it's important to talk about the key concepts of this problem and understand what we're going to be doing in this problem to get to our desired solution. So LeetCode provides us with an editorial here, and it's just going to give us a summary of the key concepts and lead us in a good direction on how to solve this problem if you're stuck or you don't understand some of the hints. So LeetCode's provided us with a closure example, and I'm going to explain the flow of this real quick. So we have this function at the top here, this outermost function called createAttr that has a parameter a. This function is known as a partial function, which I will explain here in a minute. And inside of this function, we have a return function called add, and it receives a parameter b. This function is our closure, which I'll also explain. And inside of our closure, we're defining a variable that holds a plus b, and that we're returning that variable. So let's go ahead and show this in action. So we're going to define a variable and set it equal to our outer function, so createAttr, and we're going to assign that an argument that will go in that parameter. So we're giving a the value 2. So 2 is going up into a, and it's being stored there. It's going to stay there. Now, when we call our variable add to 2, we're calling this closure. So add to 2, 5 is going to be passed into b, and inside of our closure, what's going to happen here? Well, 2 is stored, so 2 plus 5. Well, 7 is going to be stored into this variable sum, and then we're returning the sum, so we get 7. Now, the great thing about this is we can pass any value into our closure, and this value 2 is going to be stored in it. So if we, for example, could have added 10 here, well, we're going to return 12. We could have added 4. No matter what, we're going to be adding 2 to it, and because we've went ahead and stored this. So it's kind of similar to a constructor, which may be a little bit more intermediate if you are just starting programming, but I'll explain that here in a second. But this create outermost function is a partial function. And let's go ahead and talk about that. All right, so partial functions. The way I like to think about them is very similar to a pizza. Now, think about it. When you make a pizza, what do you usually always start with? Your base. So you're going to have your bread, your pizza sauce, and your cheese. That's usually the most basic form of a pizza, but we can add things like toppings to it. But what are we always starting with? That predefined bread, pizza sauce, and the cheese. And we can choose to add different toppings each time to this base. So very similar to a partial function. So function create outer is our outermost function, is a partial function. Now you can think of the value a that it is receiving as the bread, the tomato paste or pizza sauce, and the cheese. So it's always starting with that predefined base part of our pizza. Then inside our closure is the toppings we can add. We can always add different toppings to this, but we're always starting with that base. So the base won't change, but we can change these toppings, and the toppings have access to the base of the pizza because we're adding it to it. So it's very similar because our closure gets access to our partial function and its environment, which is known as the lexical environment. And let's go ahead and talk about that real quick. Now, the lexical environment is just the environment of a function pretty much. So this function create outer, its lexical environment is going to include the a and everything inside of it. And that's actually what makes up a closure, is the lexical environment and the function itself. So this is the function itself, everything that makes it up, and then the surrounding lexical environment. So this closure is always going to have access to this value a, and that is super powerful stuff. Something else I want to mention is partial functions behave very similar to constructors, like I was saying before, but let's go in a little bit more detail. So we know that a constructor, or when we use a constructor in classes, and constructors are good when we're creating instances of a object and we want to give that object predefined properties or methods. Well, same thing with partial functions. We're giving it a predefined state that we're using later in our function and just kind of adding more to it. Same thing with a class. You can have a constructor that we're giving a state and it's being assigned, and then we can use that state later. So this dot a, and we're using it later. So they behave very similar to a partial function. Constructors do, but do note they do vary in some ways, especially when it comes to memory. You can read down here that somewhere down here it talks about, where is it? Yeah, the way it's stored in memory. A lot of times classes can be much more efficient when we're dealing with a lot of methods. So if you have a lot of functions, you probably don't want to do that. You probably want to use a class instead. So there's definitely a time and a place to use which one, but it's good to know those things. And don't worry if you don't understand classes or constructors yet. You can still solve this problem without knowing those things. All right, so before we begin solving this, I promise we're getting closer to it. Let's go ahead and apply these key concepts to what we're given here. So we have this variable right here called create counter, and inside of it, it's receiving a partial function that has a parameter in, and inside of this partial function, we have a closure that is being returned, and this, of course, has access to everything inside of it and its lexical environment and the surrounding lexical environment, so in and any other value we define out here. So if we define a variable here, it's going to have access to that variable. This closure will. So now we understand those concepts, let's look at what we're wanting from this. So we're going to create a variable here called counter, and we're doing create counter, and we're sending the value 10 to it. So you can just think of that as this function right here is being sent the value 10 into n, and then from there, our counter function is somehow going to return the value 10, and then we're going to add 1 each time. So, 10 plus 1, 11, 11 plus 1, 12. So we're going to have to somehow keep track of the state we're currently on and remember that state. So definitely want to remember that, and we need to know that we need to return the initial value. So let's go ahead and get the solution. So I need to keep track of the current value we're on. So let's go ahead and do that. Let's do let current value equal to n. So whatever value gets thrown in here, so for example 10 is going into this variable current value. Now let's go ahead and do the closure function. So each time we call this, we want it to add 1. So I can do return current value, which right now that's just going to return whatever we throw into it. We want to add 1 to this. So now it's just going to add 1 each time we call this closure. So if we have 10, it's going to return 11. But each time we call it, it's only ever going to turn 11 because we're not remembering the previous value. To remember that, we're going to have to do current value, like that, plus 1. Let's go ahead and look at what this is doing. So let's run it. Well, we're getting 11, 12, 13. We're not returning the initial value. How can we do that? Well, the simplest way to do that would just be n minus 1. So now when the value 10 goes into here, the value 9 is going into here. We're going to first, then we're going to add 9 plus 1, which is going to give us 10 the first time, and every other time it's going to give us 11, then 12. So technically we are always adding 1. We're never really returning that initial value. We're always just adding 1. So that's the trick to this problem. So you see here it's accepted, we can run it. But we can narrow this code down a little bit. We could do something like plus equals and get rid of this current value right here. And that's just the same thing as before, but just shorter code. Show you that that works. And yeah, we can do it that way. There's also some other solutions that we could do. So we could do something like the postfix operator. So we could do n plus plus, which all the postfix does is it's going to initially return the value we gave. So it's going to return 10, and each time we call it, it's just going to add 1 from that. So that's perfect for this problem. So let's run it. And boom, there we go, we've got it. But we could also use the prefix operator, which just does the opposite of that. We could do plus plus n, so it's always going to add, so it would be 11, 12, 13. Let's see here, yep, 11, 12, 13. But kind of like how we done before, we can do minus minus n, which is going to subtract 1 from that value. So we get the right answer now. So 10, 11, 12. And let me just explain that a little more. So 10 is going into here. We're just going to subtract 1 from 10 is all this is saying. And then, because we're only ever going to call this function once, and the values are predefined. And then inside of here, each time we call it, we're just going to increment by 1. And it doesn't return the first because it's not starting with that. This is the prefix operator, not the postfix. Do note that this is the postfix where it would return the value we put in first and then add 1 each time. So remember that. But overall, the simplest way and the shortest way you can do this problem is with an arrow function. So you can completely get rid of this function here, and you can do return is equal to whatever we can do, like parameter, and then like this, do our arrow function, and then we can throw our code into that, which this could be a complete one-liner actually. We can do that and then do our postfix operator. I'll do it like this, and let's run it. And we're getting null. Oh, because I didn't return it. And boom, you see we get 10, 11, 12. So that is how you solve this problem. Again, I'll explain the flow just one more time. So we're putting 10 into this predefined value, which is saved into in. Won't ever change. It's the base. Inside of this, we're returning our closure, which is now this. And all we're doing is we're taking 10, initially returning it, and each time we're adding 1 each time we call this function again. So the first time, we're just returning 10, so this value. We call counter again. We're going to add this time, so 11, call it again. We're going to add 12, and so on, so on. So that's how you solve this problem, the counter. I was looking back at this, and I have no idea why I've done an arrow function like this. You completely don't need the return here. You can just get rid of that because, and the brackets, as it will automatically return this. So ignore me on that. This works the right way, and you should probably do it this way. This way is the best way. So let's go ahead and submit that so I can go ahead and show you. See, our runtime's pretty good, although it's going to be different a little bit every time. And then our memory is really good. Beats 76% of the users that have done this problem. So yeah, hopefully that makes sense. I appreciate if you made it all the way to the end of the video. I'm extremely tired, so I'm going to get some sleep. But if you like this style of video and you like the way I go into detail on these problems, or if you have any questions or concerns, leave them in the comments. I'd love to know. And yeah, let me know if there's any specific LeetCode problems you want me to break down and explain. My plan was to go through all the easy ones right now and explain just the main concepts to them, and then maybe eventually go to the intermediate and hard, and I could have do some occasional ones of those too. So let me know, and yeah, see you next time. Thanks.